So we shall wait for 5 minutes, sir.
No, no, no issues, no issues. Take your time.
No issues. The sound is.
A very good evening to one and all present here. With respect to the code, it always seems impossible until it's done. Let us begin the program with the blessings of the Almighty by playing our Tamil Thai Valthu followed by college prayer.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं धृतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिस्ततां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
On behalf of Department of Data Science, 𝒂𝒂𝒂 College, it's an honor for me to welcome each one of you to the 11-day international workshop on cybersecurity. I express my sincere thanks to our Honorable Secretary, Dr. Ashok Mundraji, beloved Principal, Captain Dr. R.S. Santosh Babu, and Head of Department, Ms. A. Vijayalakshmi Ma'am. On behalf of 𝒂𝒂𝒂 family, I, Yasir A., second year BSc Data Science, once again extend warm greeting to all. I'm honored to introduce our speaker for the 9th day of 11-day International Workshop on Cybersecurity, Dr. K. Venkatesan, Postdoctoral Researcher, Faculty of Science and Technology, National Defense University, Malaysia. Sir was an ambitious professional with leadership proficiency and assistant professor experience. He was delighted to learn about teaching, research, and development, opening academic and research institutions. Sir completed his master's in embedded system and technologies in Anna University, and also completed PhD on the topic of investigations on design of knowledge-driven DWDM system for FWM mitigation. Sir research area includes machine learning, artificial intelligence-based DWDM design, non-linearities in fiber optical systems, knowledge-driven IoT-enabled embedded system designs, and optical system design. Sir has also completed certificate courses in trending technologies such as cloud computing, machine learning, and deep learning, and also Sir was certified by Dale Carnegie Training and Professional Development Academy. Sir has 12 years experience of teaching undergraduate and postgraduate programs in India. Sir has also completed a research publication module from Elsevier Research Academy. Now I request Dr. K. Venkatesan sir to address the gathering. The session is over to you, sir.
Oh, thank you. Thank you all. I hope I'm audible. Am I audible, guys? Am I audible?
Yes, sir.
Okay,
Yes,
okay.
sir.
Thank you. Thank you very much for your kind response. Let me start the presentation. First, I'd like to share my screen. Please let me have a confirmation about whether you can able to see my screen or not. So just I'm sharing my screen now. Can you able to see my screen, everyone? Please can you acknowledge? Are you able to see my screen?
Yes, sir. Yes, sir.
Okay. Thank you very much. First of all, I'd like to thank the organizers and Ms. 𝒂𝒊𝒄𝒆 ma'am, head and coordinator of DDGDVC College, and Principal Dr. 𝑺𝒄𝒊𝒆𝒏𝒄𝒆 sir, and Secretary Dr. 𝒂𝒊𝒄𝒆 sir for giving me opportunity to discuss my recent research in consensus algorithm as well as machine learning approaches for National Defense University, Malaysia. So here I was joined as a postdoctoral researcher as well as a faculty in last month since July I have joined. So I have written a research proposal based on consensus algorithm as well as introduction of machine learning techniques in blockchain technology. We may call it as ML-𝒂𝒂𝒄𝒄. ML in the sense of machine learning, 𝒂𝒂𝒄 in the sense of blockchain-oriented cloud of things. So why I was elevated my research from fiber optic communications into blockchain with respect to cloud. So in future, everything will be related with respect to high-speed data communication. So for that, we need to work more on fiber optic communications. High-speed data communications is related with respect to fiber optic communication. And then in future, we might be able to work on with respect to store huge amount of data as well as information. In that case, we need not to go for any kind of hardware or devices at all. We can store all this information with respect to cloud. So to ensure high level of security, we need to work more on blockchain-oriented technologies. So this motivates me to do research in the field of hybrid consensus algorithm as well as the machine learning approaches in blockchain technology. Especially I'm working with respect to different types of attacks in blockchain technology. Over this introduction, along with that, let me introduce myself one more time. This is Dr. K. Venkatesan. I think you guys have received a huge introduction about myself. And apart from that, I was served myself as a recognized research reviewer in Journal of Supercomputing, Journal of Soft Computing, Concurrent Engineering and Research Applications, and Journal of Applied Nanosciences. So apart from that, I will serve myself as a research supervisor in Anna University under Faculty of Electrical Engineering. My research activity mainly involves with patent, publications, as well as FDB organized, attended. Along with that, I am also writing some research proposals to industries as well as defense universities. Well, let me begin with the session. So let me just have a brief introduction, discussion about the agenda of this presentation. Initially, we are going to discuss about the introduction of blockchain technology, and then what makes me to do research in the field of blockchain technology. So based on the problem statement, we have reframed the goal, the design flow, as well as the proposed system and software tools, performance matrices. And finally, we are going to discuss about the expected outcomes. Of course, these outcomes we have been tested with respect to a real-world test bench, blockchain infrastructure test bench, which is at Proxima X. So we are working on the real-world problem. So all those content we are going to discuss in detail. Since I'm working with the Defense University, so I'm not allowed to discuss almost all kind of detailed informations. So under my restrictions, I can able to show you a glimpse about what kind of research we are doing in National Defense University, especially in cybersecurity. Okay, let me begin with the introduction. So blockchain technology. So blockchain technology is nothing but a decentralized and distributed ledger. So what is decentralized and distributed ledger? In what way it might get differs? Let me take an example of banking sector. In banking sector, we are having a user 1 to user 2. We are trying to transact some money from user 1 to user 2. In between user 1 to user 2, we may have a third party. The third party is nothing but a bank. So whereas in blockchain technology, we don't have that kind of third party. So that's why the banking sector, we may call it as a centralized system. Whereas the blockchain technology, we may call it as a decentralized system. And next one is a distributed ledger. So what does it means? It means very simple. So we may have n number of users in a blockchain technology or for a single transaction. So for that transaction, at the end of the transaction, each and every user having the same master copy of transaction what user 1 to user n it might have. So that's why it is called as a distributed ledger. And of course, it will always enables a higher end security as well as transparent as well as a tamper-proof record keeping. So what makes the blockchain technology more special about security, transparent, and tamper-proof record keeping, which means that this leads to introduction about a consensus mechanism. So what's the need of consensus mechanism? In banking sector, we may have the hackers or intruders. They can able to they can share some set of links. With the help of that link, they can able to receive some OTP, or they can hack our mobile phone. They can able to do their own transaction. They can able to get our informations. Okay. So whereas in blockchain technology, it's very difficult to do like that. So why in the sense it might be leads with respect to implementation of this might be leads with respect to the implementation of the corresponding consensus mechanism. Okay, so let me have the role of consensus mechanism. And consensus mechanism in blockchain technology, we may have n number of users. Imagine that we may have n number of users. So n number of users along with the original users, we may have intruders also. So what that intruders will do? The intruders will leads to develop or generate a bad node or bad information that will leads to attack our blockchain infrastructure. So here we are trying to introduce one mechanism, is nothing but consensus mechanism. It able to prevent that kind of attackers as well as the bad informations as well as the malicious intruders. But along with that, in real world scenario, in blockchain technology, one person, user 1 is going to be connecting with respect to higher end fiber optic communication, whereas another user is going to be connected with respect to normal mobile phone data network. So this will leads to introduce different latency, network latency, as well as different timestamp. So these problems will be clearly solved through with the help of consensus mechanism. That's why when we talk about a blockchain technology, so consensus mechanism will be acted as a key factor that will enables the security of this blockchain technology. So even though we have developed this kind of higher end consensus mechanism, especially in microgrid systems, this is one of the application in energy efficiency. Here we might be limited with respect to very less number of nodes. So this makes intruders can easily attack the microgrid system, and that will lead to compromising the integrity of the network. So this could be the recent problem what we are having in blockchain technology. So along with this recent problem, let me have a problem statement. So problem statement in the sense, here I was mentioned only one problem statement, which is nothing but Ethereum Classic. I hope here you can clearly see this. Here you can clearly able to see this. So this could be the main problem statement. But we have to keep one thing in our mind. This is not one and only the problem statement. This problem statement, this kind of attack in Ethereum Classic network has been happened over the period of 2019. The same year itself, the same kind of attack will be happens in Zencash as well as Verge infrastructure platform. In 2022, Binance is nothing but the biggest cryptocurrency corporate company. So that company is also went into huge attack. They might have lost around $570 million US. And recently on April 2023 in South Korea, the JITAC hack might be happened in April 2023. They might have lost around 14 million USD. So these are all some real world problems that happens in a blockchain industry, especially in the infrastructure industry. Even though we may have consensus algorithm, even though we have a number of consensus algorithm, these kind of attacks will be frequently happen. So this makes me to work more on this blockchain field. So based on this, I have written a research proposal. I've submitted this research proposal to research proposal to National Defense University in Malaysia. And finally, they approved my proposal, and they are giving me a job as a faculty as well as a postdoctoral fellowship in National Defense University. So intruders plays a key role that going to be, these people are going to be attack the blockchain infrastructure network through some malicious activities or some unstabilized as well as some security oriented cracking activities. So what our expectation is nothing but we need to develop a new consensus protocol. Otherwise, we can go for some sort of a modified consensus protocol that will mainly help us to validate the effective blockchain transaction, and it will eliminate some different type of attack. Either it may be 15% of attack, or we can go for cyber attack or double spending attack or whatever it may be. So we are trying to develop a consensus protocol. So how we are going to be develop consensus protocol? Is that enough? No. Developing consensus protocol is not only enough, but along with the developing consensus protocol, we are here to develop some machine learning oriented approaches. So these machine learning oriented approaches will play a key role in 3 different sectors. One is working with respect to blockchain transaction, and next one is working with respect to developing a consensus protocol based on real-time attack. And third one is we are going to be working more on a prediction model that will help us to identify what kind of attack and if to be able to respond immediately to the attack. So these are all our problem statement. Based on the problem statement, we are trying to elevate ourselves into reaching our research goals. So next, what we are going to discuss is nothing but the goal of this presentation as well as my research. Here, the first thing is I want to enhance security for the microgrid system. It will effectively detect and respond to the attack, which means that effective detection of what kind of attack in blockchain network security that will play a major role. This could be the first goal. And next one is impact over the attack across how we are going to be respond to the immediate attack, which means that whatever the attack might be happened, how long the attack will take over the control of the corresponding blockchain network, that will always plays a key role. If the attack might be happens for a few seconds, the impact will be very less, we may lose very few informations. If the attack might be taken for a longer period, then the impact is also somewhat higher. So once we received an attack, once we identified a malicious intruders or malicious user, immediately we have to strengthen our security. So for that purpose, this will be acted as our second goal. And third one is we are trying to work more on improving the efficiency about the consensus algorithm as well as the machine learning approaches. So in real world scenario, we are having more than 50 to 60 consensus algorithm. But so what's the beauty of our own developing consensus algorithm? It seems to be getting different. Okay, so that's we are going to discuss in upcoming slides. And next one is once we talk about the machine learning oriented approaches. Sorry, 1 minute. Yes. So once we talk about the machine learning approaches, the importance of machine learning approaches is nothing but we are always trying to keep updating as well as adapting our system for the real world scenario. For that, we need to focus more on some sort of supervised, unsupervised, as well as the reinforcement learning. I hope you guys might be aware of reinforcement learning. Let me go with a small example about reinforcement learning. Imagine that a person is playing online chess with respect to AI bot. So now what that AI bot will do? The AI bot will clearly try to understand the capacity of the person. So then that AI bot will tune by its own to meet the capability of the persons, like Pragyananda. Pragyananda is a very good chess player. So AI bot will adapt by its own by understanding the playing model of Pragyananda. So if some person who those who not know how to play chess, for that person also AI bot will ready to adapt. So which means that we are trying to adapt our machine learning algorithms, or we are trying to develop our own systems that will immediately respond or adapt based on the real world scenario. This could be the challenging task in our goal. And finally, we are trying to identify the real world threat detection. Since I'm working with respect to Defense University, I'm always ready to focus on real world attack as well as the real world scenario. So for that reasons, we are focusing more on machine learning part along with these three different subsections. One subsection is clearly based on what kind of blockchain infrastructure we are going to be using for. Our next subsection will be discussed with respect to hybridization of consensus algorithm with respect to machine learning model. And third one is we are trying to tune the machine learning model based on real world requirement. So these are all our research goals. I hope you can clearly understand about these concepts. If you have any doubts, please let me know. If you have any doubts, please let me know. Am I good? Shall I proceed with that? Yes, I need acknowledgement from any one of you. Am I good? If you're having any doubts, please let me know.
Yes, sir.
No, sir.
Okay. So I can proceed. Thank you. Okay. So this chart will clearly discuss about the design flow of our research proposal. So first, what we are trying to do in the sense, we are trying to work more on literature review about existing consensus algorithm as well as the limitations in microgrid. Since my project is involved with the microgrid system, especially I'm focusing on energy efficiency system, so I need to understand the importance of minimal nodes as well as the limitations of microgrid systems. So initially I performed a literature review, and based on that, I'm trying to design a new high-level hybrid consensus algorithm. So what is the form we are going to be using for? And next one is what kind of hybrid consensus algorithm we are going to be working for. So here I was proposed with respect to 4 different algorithms. One is delegated proof of stake and work, proof of stake and work, proof of Casper, and delegated Byzantine proof of stake. So these are all the 4 hybrid consensus algorithm I'm going to be proposed under Proxima X blockchain platform. Since Proxima X is a blockchain infrastructure service provider, and they are our industrial collaborator, and we are working with Proxima X. So they are asked me to develop some new hybrid consensus algorithm. So we have developed. I'm going to be working on that particular Proxima X blockchain platform. So after performing these transactions in a blockchain, we are going to collect that data through the Proxima X as well as some other data providers. After collecting all those data, we need to go for a data cleansing process, collecting the data, analyzing the data, and classifying, labeling. All kind of data cleansing process will be clearly done. So after that, I'm trying to be working with respect to the corresponding machine learning approaches with respect to supervised, unsupervised. Sometimes we can go for rule-based approach. So why we need to go for rule-based approach? That might be clearly based on real-world scenario as per the real-world problems. And along with that, I can able to include with respect more reinforcement learning approaches also. And recently, we are working with respect to some sort of genetical algorithms for recent related networks. So we need to focus more on developing consensus algorithm for the particular platform and integrating machine learning approaches. When we are trying to be integrating these machine learning approaches, we need to focus on 2 important things. One is we need to clearly respond to the machine learning lifecycle. And next one is we need to develop a responsible machine learning approaches, which means we need to understand, we need to protect, we need to control what kind of machine learning model we are processing with respect to that. So we need to work on this kind of process in a clear way. So after that, we are trying to be understanding our proposed model through the performance matrices. Here I listed some set of performance matrices, but I'm not allowed to discuss more on this kind of performance matrices. And finally, we are trying to be deploy our proposed system into the real world scenario and monitor the proposed system, how it will behave in a real world environment. And based on that, we are trying to get a feedback, as well as with the help of that feedback, we are trying to improve our proposed system into the real world environment. This is what our corresponding design flow. This could be the proposed system. This could be a basic, simple proposed system for our research process. So here we are having a blockchain network layer. This might be related with respect to public blockchain. Here, this blockchain network model will be developed for Proxima X, a blockchain infrastructure provider. So through this, we are trying to be develop more than a number of transactions. We are trying to be analyze these transactions through transaction pattern. Meantime, we are trying to be collect data set from the corresponding infrastructure provider, blockchain infrastructure provider. The data set might be structured data, semi-structured data, or unstructured data, whatever the data set it may be. We are trying to be collect all the data set, and we are trying to performing a data balancing process. So data balancing in the sense we are trying to be clear all the semi-structured as well as unstructured data into the structured one. Then we are trying to be process that complete data set into 60 to 70% of data set for a training model, and 15 to 20% of data set for testing data, and remaining 15 to 20% for data validation process. So through the training data, we are trying to be process the data into the learning model. Here, the learning model will be clearly involved with respect to supervised learning, unsupervised learning, reinforcement learning, or the genetical algorithm which has been required for the real world scenario. After that, we are trying to be developing a proposed trained model. So through the trained model, that model proposed will be processed with respect to deployed model. So this deployed model will clearly works with respect to the real world scenario as well as the machine learning model. It will be processed of both the things, and finally it will lead to develop a perfect prediction model based on real-time scenario. Here I can use the word perfect, but in the sense still we are working to improve the efficiency. So that might be more with respect to 85% of efficiency, and we are working more. Me and my team, we are having a separate team. We're working together more on to increase the efficiency, to identify the types of attack as well as the anomaly detections also. So this could be a simple proposed system. So after discussing this proposed system, here we are having a small glimpse about the flowchart of one of the consensus protocol what have been developed. Imagine that we are not going to be stopped with only one of this consensus protocol, which means that we are developing n number of consensus protocol. I mean, we have developed a 4 consensus protocol. A machine learning model will be involved in this consensus protocol. It will be able to select what kind of protocol we need to work in an immediate way. What kind of protocol? Sometimes we need to work for delegated proof of stake, or sometimes we need to work more on proof of stake, or sometimes we need to focus on Casper, or sometimes we need to focus on Byzantine. So based on the problem, we need to immediately shift with respect to the requirement of the protocol. Okay, so for that purpose, we have been developed some hybrid consensus protocol. So here, let me have the glimpse about a simple one consensus protocol. So this protocol will discuss about a delegated proof of stake and work. Okay, so here it will begins with the basic initial transaction. Based on the transaction, it will initialize with respect to either it may be considered what kind of consensus mechanism, or the attack or the problem may be considered which consensus algorithm will be based. In this part, it will be focused on delegated proof of stake as well as a proof of work consensus mechanism. So it will check for whether the block is valid or not. If the block is valid, then it will goes for corresponding delegated DPoS delegated purpose block. If it yes, it will stick. If it lies on yes, it will clearly stick with respect to the corresponding DPoS block. Otherwise, if the block validation is not performed by DPoS, then it will go for POW. But in some other cases, this corresponding block validation may not be performed by proof of stake or proof of work. In that case, that block validation will directly goes to end state. That will directly go to end state, and it will shift into some other consensus protocol. Here we listed this consensus protocol: DPoSW, POSW, proof of Casper, and proof of stake, and delegated Byzantine proof of stake. So likewise, so based on the attack. So based on that immediate attack, so we are developing a model, a machine learning model with hybrid consensus mechanism that will help us to immediately switch over within a fraction of microsecond. This model we tested in real-time scenario using Proxima X test bench. This we tested. For that, it will consume maximum of 1 to 2 microseconds to switching with respect to consensus protocol based on attack. The attack will be developed by our own attack. We have developed our own attack. So for that attack, it will immediately switch over. For that, it consumes maximum of 2 microseconds. Even the 2 microsecond will play a crucial role in real world scenario for blockchain attack. So this slide will clearly discuss about a comparison of our proposed consensus algorithm. Actually, I want to discuss more about this kind of delegated proof of stake, but this flowchart as well as algorithm, everything will becomes under patent as well as this might be confidential one. So that's why I'm discussed with only one algorithm. I'm moving on with respect to some sort of a theoretical approach. So this slide will clearly discuss about the comparison of our proposed consensus algorithm. Here, we proposed almost 4 algorithms. These 4 algorithms will have somewhat unique strength in the sense of what are all the disadvantages we are having in real world scenario. Almost all kind of disadvantages in real world scenario. Here we have met and we have make some sort of a higher end efficient system. It can, so let me take an example of delegated proof of stake and work. It performs high transaction throughput and very fast transaction. It's highly secure against 15% of attacks. In POSW, it's working with respect to low energy consumption. Whereas in DPoS, it reduces all kind of computational requirements, faster block confirmation, so high transaction throughput, so better scalability, and it's mainly working with respect to against Byzantine failures. So all kind of disadvantages we have been overcome. But even though we overcome all these disadvantages, our proposed method will lead to some set of limitations. So here the major limitations is nothing but complexity and implementation challenges. Since we talk about a high-level implementations of consensus algorithm in a real-world scenario, it might be clearly based on n number of users. That might be clearly based on n number of users. Initially, we are testing with respect to maximum of 100 users. For 100 users, this consensus algorithm will be good, performing in a fast mode of immediate response. Whereas when you're trying to be increasing with respect to more than thousands of users, it will lead to some set of complexity. So this will be the real world scenario, real world problem, what we're having in complexity as well as the implementation challenges. This could be the first one. And next one is one of the important problem is nothing but network latency. The main need of consensus algorithm is nothing but different users using different levels of data net. Some people may use fiber network. Some people may use mobile network. But in real world scenario, we need to manage all kind of network latency. So this could be the real world problem. So for this, what we are trying to propose in the sense, we need to develop a high-speed fiber optic data communication network structure. Since my research involves with respect to high-speed optical structure, I proposed in Defense University in Malaysia, I proposed a special high-speed data communication. It will help us to overcome all kind of non-linear fiber optic issues in high-speed data communication issues. High-speed data communications. I'm mainly focusing on these 2 limitations, and regarding this formal verification as well as the proof of the real world scenario, we are trying to get help from our Proxima X service provider, which means our infrastructure, blockchain infrastructure service provider, and they are also accepted our request, and they are also now involving for this kind of formal verification and proofs. And apart from all these limitations, we are having very huge scope for developing our real world prototype to meet the real world scenario. So this could be the overall comparison of our proposed consensus algorithm. But this could be restricted with respect to limited number of users in our lab setup, in our center of excellence, in our lab setup. We have developed 100 users. For 100 users, we have tested all these algorithms in a real world scenario. The work will be started over the period of December 2023. I started to doing this work in December 2023, but have joined here in July. So almost 6 to 7 months before we started our background working process. So with the help of this kind of a detailed study, which makes me to moving with respect to very fast mode of results in real world scenario. The corresponding software tools what we used in our lab setup is nothing but first thing is focus on consensus algorithm. As regarding this consensus algorithm, already we discussed about we are working on hybrid consensus algorithm related with respect to proof of stake and work and delegated proof of stake and work, Byzantine proof of stake and proof of case. And when in order to work with respect to machine learning frameworks, here I'm mainly using with respect to MATLAB toolbox because I could be familiar with respect to MATLAB coding as well as a MATLAB toolbox. I'm working more on MATLAB toolbox, but along with that, some of my team members also working with respect to TensorFlow also. They are working with respect to TensorFlow. When we are talking about the blockchain platform, we are working currently, we are working with respect to Proxima X, and we have proposed a detailed research proposal for Ethereum also, which means that in order to increase in order to increase more number of users, not only with respect to a single platform. The thing is, we are trying to distribute more number of users with respect to different platforms. For that, we are approaching with respect to Ethereum as well as Hyperledger Fabric infrastructure providers also. Regarding security tools, this could be plays a key role to develop a higher-end security for background process of a consensus mechanism. I'm working with the IPFS, and for development tools, I'm writing code using some set of Python language. The algorithms has been developed as well as the coding models will be developed through the help of some set of Python language as well as R language. For visualizing tools, I'm trying to be using with respect to matplot library function as well as a plotly, and some of the visualization has been performed with respect to some Minitab tools also. So what kind of software tools we are using, we are working on this platform will be clearly depends on based on our real-time trade-offs as well as the real-time our infrastructure service providers. So we are work based on our infrastructure service provider. So they are our boss. So we are going to work for them. So we are going to meet their real world requirement. So this will clearly help us to improve the computational efficiency also. So I hope you can clearly understand this. If you have any questions, kindly let me know about this. Am I audible?
Sir, this MATLAB toolbox or Python toolbox, I mean, these tools can be understood by the science background faculty or people, sir. But what about the commerce and management? Do we have any particular software tools where we can use them easily?
Okay. For commerce as well as for other people's, actually MATLAB toolbox is very easy to understand. When time permits, I can able to give one more brief lecture about how we can use MATLAB toolbox for machine learning approaches. This could be easily handleable for each and every tools, even for commerce tools, commerce students as commerce faculty also.
Okay,
so no need to worry about it. If time permits, I can go with one more lecture about how we can effectively use MATLAB toolbox for all kind of applications.
Okay, sir. Thank you, sir.
Thank you. Any other doubts? Okay, in that case, I can move forward. Okay, so this could represent the performance matrices. Actually, when we talk about this performance matrices, we are having more than n number of performance matrices tools as well as analysis. But here I'm restricted to show some basic information. Okay, the first one is these graphs, these details, all those I was obtained only through MATLAB. This could be obtained only through MATLAB, and accuracy, precision, all kind of callback functions will be clearly obtained through only MATLAB. In order to define very higher end accurate probability oriented approach for a good of fit model, our proposed model. One is simulated model, next one is predicted model. To enhance our result, to show a better projection of our result, I used Minitab, and then we have developed some mathematical model. when basic mathematical model. Even if I'm going to be talk about mathematical model in the sense, no need to panic. Here I'm going to use only basic 10th as well as a 12th mathematical modeling approach to solve this kind of problems, which means that once we are very good about our basics mathematics, that will help us to solve almost all kind of real world problems. So one of the clear request to everyone is nothing but please try to understand our basic maths. That will give you an overview, that will give us a clear view about how we are going to approach the real world problem. Okay, so let me come into this performance matrix. So in this confusion matrix, based on the transaction pattern, we have classified our transaction patterns with respect to 3 different levels. One is good, better, and low. Good, it performs for good category, our proposed model performs well, as well as for lower category also our proposed model performs well. Whereas for better category, here it will introduce some set of flaws, which means that our proposed system is not able to identify almost all kind of attacks. So it will lead to get failure. Even for 100 nodes, it will lead to get failures to predict a better transaction pattern. Okay. Next one is a good-of-fit model. This good-of-fit model will be clearly developed only through with the help of the basic multiple regression model, which has been developed from basic mathematical equations. That multiple regression model relations might be correlated with respect to obtained R value. When an obtained R value will be somewhat high, which means when R value will be lies between 0.8 to 1, then it will show high level of correlation. For that high level of correlations, my simulated model as well as a predicted model will exactly lies. But for our proposed approach, that R square value we obtained is nothing but the moderate value, which means that the value might be lies between 0.5 to 0.7. So for that case, some of the patterns will be exactly lies and some of the pattern will get deviates. So that's why this deviation will be clearly reflected in confusion matrix, and this deviation will be clearly shown in moderate level of correlation, and this will result a small deviation. Here you can clearly understand how the deviation will be happen. The blue dot will represent for our simulated model. The red dot will represent for our predicted model. So this will show how these models will get deviated. So some of the models will be exactly lies, but some of the model will get deviates. So this kind of deviations, what we obtain in a real world scenario. So likewise, so based on this, we have analyzed some other performance matrices also, like accuracy, F1 score, precision call, all those parameters also we are having, but I'm restricted with only this kind of informations. This pictorial informations will be clearly help us to understand how our proposed machine learning model will be able to identify our transaction pattern as plus attack, and how it will deviate for minimal 100 users. Imagine that when I'm working for more than thousands of users, maybe 1 lakh of users, so how this model will be? It will be get completely collapsed. So which means that we need to train our system, real-time systems for based on our real-world scenario. So which means it will automatically emerge with respect to more number of reinforcement learning-oriented approach. So we might have a number of user attackers. So with the help of that attackers, we need to immediately respond. So based on that response, we have to prevent the attack. So likewise, we have to simultaneously work more on real world scenario. So this is what we are doing now. So I hope you can clearly understand the research problem as well as the difficulties what we are having in blockchain network through this performance matrices. So after analyzing all these performance matrices as well as our proposed system, we can expect how our outcomes will be for the real world scenario. Since it has been taken around 7 to 8 months to solve this problem, a minimal level step approach. We have done a minimal level step approach. This will clearly help us to detect as well as respond to our attack in a real world scenario, and it will help us to maintain a upgraded level of integrity in our blockchain platform, especially in Proximax. And it will help us to do a smooth energy efficient operations in microgrid for 100 users. And of course, our proposed model will still equip by its own for evolving new level of threats. Initially, we started to work more on 51% of attack, but now we are extending our research work with respect to civil attack, and then we can focus on more on double spending attack, and we are more working with selfish mining attack, and currently we are improving ourselves with respect to some huge number of anomaly detections also. So all these factors will motivate us to improve the higher end security platform, higher end security for our blockchain platform, and this will lead to choose or develop an efficient consensus protocol. Since the efficiency in the sense that not to be 100%. 100% efficiency, that won't be practically possible. Of course, we can able to reach maximum of 90 to 95% of efficiency in real world scenario for maximum user. That could be the great achievement. So currently we are focusing on this this part where we are trying to developing more efficient consensus protocol with respect to with the implementation of machine learning approaches. So these are all our expected outcomes. So based on these outcomes, we may have our performance matrices also, and this could be a SWAT analysis of our hybrid approach. Since I'm not allowed to show you a detailed block structure, so I was compressed all this detailed block structure into a theoretical approach, just I was discussing with you. So this part will clearly show that our proposed methodology, this methodology will consist of our blockchain platform and corresponding performance parameters or parametric optimization with respect to machine learning. So this will lead, our proposed implementation will lead to introduce various strength. First one is strength. Okay. Next one is we may define it as opportunities as well as a weakness. Opportunities as well as a weakness. In the sense, we need to focus more on parametric optimization as well as performance monitoring. So based on users, based on transactions, based on infrastructure developers, the parametric optimization as well as performance monitoring factor might be devious. So we need to train our machine learning system that move on with respect to intelligent decision making. We need to develop our own intelligent block validation. That intelligent block validation will make our systems into a dynamic adoptions. It will do an effective predictive analysis to do this optimization. This could be our weakness, and we need to work more on this. And regarding the security enhancement, till now we have to up to 70 to 80% of security for 100 users. But what we are trying to do in the sense, maybe this project will be maybe continue for more than 2 to 3 years. Up to 3 years, we can able to develop for maximum number of users. So this will lead to provide a very good higher-end security enhancement. But the real challenge where we are going to face is nothing but the complexity of our proposed approach. The complexity in the sense that still now we are struggling to get very huge quality of data as well as very good quality of data communication. So once we are well set to establish high-speed data communication in terms of 1 GB or 2 GB. I think one of my friends working in Nanyang University, Singapore. So they have in their lab, they have established a real-world setup up to maximum of 10 Gbps. So we are trying to get help from them. So when we are working for more than 10 Gbps per second of data communication, maybe that might be very good to do and more number of effective transactions. So this could be one of the real-time challenge what we are facing now. And one more problem is that this could be a complexity requirement and data as well as the computational overhead. And based on this computational overhead, of course, we are trying to be talk with our Malaysian governments regarding introducing some set of regulatory as well as legal considerations to develop security for blockchain infrastructure providers. So these are all the real-time limitations and challenges what we're focusing on. This I'm going to be defining it as threats. In meantime, we can define it as an opportunities to enhance our blockchain network. This will be considered as a threat as well as opportunity. We may consider this could be a threat as well as opportunity. And finally, this could be a small glimpse about our proposed experimental setup. So since we work with only microgrid systems, we focus only on energy efficiency, but the blockchain technology will easily widespread their wings with respect to in various sectors like educational sector, medical field, financial field, especially in defense intelligence and identifying an unknown object or unknown persons through a God-side protocol. This could be for defense intelligence. So we are working more on these kind of approaches. For these kind of approaches, we are trying to develop a common template. Of course, the common template may not be suitable for all kind of approaches, but we need to change some slight changes in this experimental test setup. So this will help us to perform an effective development of real-world blockchain infrastructure. So I hope you can clearly understand this test setup. And this block will be clearly represent for smart devices. Nowadays, each and everyone carrying mobile phones. Now home will become smart home. TV will become smart TVs, which means that we are having IoT, Internet of Things, sensors, and smart devices. Through these kind of devices, we can able to collect huge number of data informations. This we can use for corresponding platform. This we can use for educational platform, or we can use for medical platform, or we can use for defense intelligence also. We can use for defense intelligence also. So this could be the one sector. And another sector, we can focus more on corresponding blockchain platform with respect to types of attack. So when I'm going to be combining all these two with respect to machine learning oriented approaches, this is nothing but AA module. This I'm going to define it as AA module. With the help of this, we can able to segregate different levels of machine learning approaches. This will leads to a higher end effective, efficient proposed system and performs the higher end prediction, as well as it will do a one automated what we can say. So we can define it as intelligence-based system. The system will perform by its own. Based on attack, the system will respond immediately. Based on attack, the system will immediately detect the anomalies based on the types of intruders as well as attack. So this could be a basic overall experimental setup, what we are going to be proposed. Okay. So based on this complete research, have been proposed 3 research patents under Malaysian defense, and we have communicated 4 research journal papers to high-level publishers like IEEE, Elsewhere, and Springers. So this is what I have been working in Malaysian defense for hybrid consensus protocol. I hope you can clearly understand my research flow. If you're having any doubts, please let me know. I'm here to answer these questions. I hope this could be the last slide. And I would like to thank everyone for giving me the opportunity. Especially I would like to thank our participant for spending their time to understand these concepts. Okay. So if you're having any questions, now I will be happy to answer. Any questions? Everyone, any questions?
Thank you so much, sir.
Yes, thank you.
With respect to the code, the best way to predict the future is to create it. It's such an honor for me to get the opportunity to thank you all. On behalf of Department of Data Science, 𝒂𝒂𝒂 Vaishnav College, I would like to express my gratitude to all esteemed delegates of program for their presence and contribution to make this event a great success. A special thanks to our Secretary, Dr. Ashok Mundra ji, and our Principal Captain, Dr. S. Santosh Babu sir, for providing immense support. I extend my gratitude to our Honorable Dr. K. Venkatesan sir to take out time for his busy schedule to share his knowledge with us. I must thank the organization team, our department faculty members for working hard to make the 9th day of International Workshop on Cybersecurity successful. Last but not the least, I thank all the participants for your active participation. Thank you, everyone. Once
Thank
again,
you,
for
thank you,
making
guys.
this day victorious, I request everyone to pay respect to our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय
Thank you all. Now I request the participant to kindly fill the feedback form. The link has been pasted in the chat box.